Hello and welcome everyone to day 10 of our low-level design course. Today marks an important milestone. We will move from pure theory into practical, real-world application of LLD concepts. Our focus will be on designing a library management system, a classic case study that captures many core principles of clean, scalable, and maintainable design. Throughout this session, we will apply the tools, techniques, and patterns we have learned so far, culminating in a complete low-level design. Let's dive in and start shaping systems like true designers. Before I start designing, let's first understand the scope and vision of today's project. The library management system we are about to design is intended to manage all day-to-day operations of a typical library. This includes cataloging books, allowing users to borrow and return books, keeping track of overdue items, and maintaining accurate inventory. We will take a requirements first approach, carefully identifying what needs to be built and ensuring that every design decision we make ties back to these functional needs. The emphasis will be on creating a modular, extensible system that can evolve over time without major rewrites. Let's start by framing the high-level requirements. The system must allow users such as students, staff, or guests to search for, borrow, and return books. It must help librarians manage book inventory by adding new books and removing outdated ones. Additionally, the system should track book availability, calculate overdue fines, and generate basic reports like most borrowed books or user borrowing histories. Importantly, it should support multiple copies of the same book, distinguishing between individual book copies rather than just titles. Remember, gathering clear requirements upfront prevents costly rework later in the design phase. Now that we have a clear understanding of the requirements, let's translate them into key components and classes. First, we have the book class, which represent individual books with attributes like title, author, and ISBN. The library class will serve as a central manager, coordinating users, inventory, and transactions. We also need a user class with types like student or staff, each with different borrowing privileges. The loan class will track the borrowing and returning events, capturing dates and statuses. A catalog class will handle book search and lookup operations, while an inventory class will keep track of the available copies. This decomposition ensures that each responsibility is well contained, setting us up for a flexible design. Applying solid principles is the bedrock of building a scalable and maintainable system. Firstly, under the single responsibility principle, each class in our design will handle only one well-defined responsibility. The open-closed principle reminds us to design classes that can be extended, for instance, adding new user types without modifying existing code. Following the least scope substitution principle, subclasses like premium user or guest user should be substitutable wherever a regular user is expected. The interface segregation principle urges us to keep interfaces lean, a searchable interface for catalog, for example, separate from a borrowable interface for users. Finally, the dependency inversion principle means high-level modules like the library class will depend on abstractions, not on concrete classes, making the system more flexible to change. To better visualize our system architecture, we use UML diagrams. First, the class diagram will depict all our classes, their attributes, methods, and relationships like associations and compositions. It will show, for example, how a library has a catalog which manages many books. Next, a sequence diagram illustrates runtime interactions, such as how a user searches for a book, places a hold, and completes a loan. We can also use activity diagrams to map out overflows like book return or fine calculation. These diagrams are powerful tools for communicating our design to stakeholders, teammates, and future maintainers. Once the design is finalized on paper, we bring it to life through code. The book class encapsulates all book-related details such as title, author, subject, and availability status. The library class contains methods like borrow book and return book, orchestrating interactions among books, users, and loans. The user class has methods to check availability and track borrowed items. Notice how each class is cohesive, focused, and open for extension, aligning with solid principles. Moreover, dependency injection can be used where appropriate. For instance, injecting a search strategy into the catalog. Through the code, we prioritize clean structure, readability, and modularity. A robust system anticipates and gracefully handles errors. What happens if a user tries to borrow a book that's already checked out or returns a book past the due date? We will design specific exceptions such as book not available exception for borrowing errors and overdue fine exception when calculating fines. Handling these cases elegantly through custom exception classes keeps our code clean and make failure states predictable and manageable. We will also reinforce validation like checking that a user hasn't exceeded their borrowing limit before allowing another loan. Edge cases are not afterthoughts, they are an integral part of a professional design. Maintaining clean, readable code is a non-negotiable standard in professional development. We adhere clear naming conventions. For instance, methods like reserve book are immediately understandable. We use meaningful class names, keep functions small and focused, and write descriptive comments where necessary, explaining the why, not just the what. Refactoring is continuous. As our code evolves, we look for opportunities to remove duplication, improve clarity, and separate concerns. A clean code base isn't just easier to read, it's easier to debug, extend, and scale. At this stage, we consolidate our work. Our library management system design is modular, adheres to solid principles, and anticipates real-world scenarios with proper error handling. The use of UML diagrams clarifies system interactions, while clean code practices ensure long-term maintainability. This design is flexible enough to accommodate future changes, like adding features such as ebook borrowing, reservations, or even a recommendation engine. Remember, a well thought out low level design is the foundation upon which great software is built. That concludes our deep dive into today's test case study. Through this exercise, we have seen how to bridge the gap between abstract principles and real world system design. I encourage you to try building this system yourself, either individually or in small teams, and see what design improvements we can bring. Now let's open the floor for questions. Feel free to ask about any aspect from requirements analysis to solid applications, UML diagrams, or coding best practices. Thank you for your active participation and focus today. You are one step closer to becoming a true system design expert.